Yeah.
Okay, well, I think we can kick off. John, if you'd like to do an intro. Thank you.
Right, I will do that. So first of all, welcome to everybody that's tuned in to this workshop that's run between Locus and Safe Software. It's a real pleasure, as always, to be working alongside the Safe Software team. Today we're going to have Don Murray, who's co-owner of Safe Software and the person who actually started Safe with Dale all those years ago, back in 1993, when I was playing cricket at Hugo Rowe Park, and Don and Dale were in some garage coming up with a brilliant idea of FME. So it's a long time ago. Artie, who looks after all of the partner network in the Australia, New Zealand, Pacific North America area, is alongside us as well. So it's great to have Artie. From my perspective, I just want to say thank you to Angie and to Ruby, who have come together and put together these 4 days of workshops with some of our clients. So we hope that you guys get a lot out of them as well. So it's a real pleasure, as I say, to introduce Don Murray. Don and I have known each other for quite a long time now. We've had the opportunity to do several of these. We've done some in-person presentations in New Zealand and Australia. And one of the great pains of COVID is our inability to be able to travel up to Vancouver to meet with the team in person as we would normally do once or twice a year. And of course, not being able to do this for the World Congress as well. But, we all have our fingers and toes crossed and a few other things gone. We really hope that 2022 is the year that we can get up there and that we can meet all of you guys again and then all the other users around the world. So without any further ado, I'm going to turn this over to you, John. Thanks so much for taking the time and effort to putting together a presentation on dynamic engines. Really looking forward to hearing what you guys got to say and showing us how you can get best use out of them. So thanks so much, John.
Okay, great. Thanks, John, and thanks everybody for attending this. What I'm going to go over is what dynamic engines are, how to get started with them, and I'm going to walk through a number of demos that show you how to use them. So the first thing to understand is dynamic engines are all about you being able to deploy enterprise integration in an agile way so that it can grow to your needs and not have to worry about the low-level technical details. So anyway, and you're going to see the amazing flexibility they have. So okay, so are we on the next slide, Artie? Our strength? Perfect. Okay, it's working. So yeah, so many of you use FME or you're aware of SAFE. And the thing that separates SAFE from other vendors who are in the enterprise space is we have comprehensive support for spatial data. There's no other vendor in the world that's in our space that has the same level of support for spatial data. And we bring it to organizations so they can do what they want to do with all data, and that's make decisions. And so that really is the differentiator from SAFE from others. We've been recognized for the second year in a row. We're on the Gartner Magic Quadrant for data integration tools. And so you can see us there. This whole thing is the Magic Quadrant, and you can see there's like only 20 or 18 vendors that are identified. And our strength, again, when we look at all of these, is all around spatial data. Okay, and dynamic engines, what FME does, the FME platform, it's all about enterprise automation. We've done things in the past, we talked about spatial ETL, which is a part of enterprise integration. But now with the major things that we've added to FME Server, you can see that FME Server is all about enterprise integration. And in fact, it's the only enterprise integration solution with comprehensive spatial data support. There are some others that understand what a longitude and a point is, but spatial data is so much more than that. It's imagery, it's point clouds, it's 3D, it's buildings, it's indoors, outdoors, it's so many different things. And FME is the only platform that supports all of that. Okay, so the benefits of automation, of course, save time, increase productivity, increase efficiency. So now the enterprise integration application is moving the data back and forth, minimize errors. A lot of times before automation, people would have to double code. So they have to enter things in one system, and then they have to do the same thing in another system. And people are terrible at that. That's not one of our strengths. And also to automate things, we often say it's safe. First, let's figure out how we would do it manually, i.e. come up with a standard process. Once we define a process, now we're in a great position to automate it. Better customer experience, getting people the data they want quickly in a really easy form. And that's, you're going to see FME server apps, that's all about that. And of course, scalability. As an organization and enterprise automates more and more, they need the system to easily scale so that they can add processing capabilities to meet all these requirements. And again, automation and dynamic engines, of course, are a big part of that. So the types of automations that we do in FME server, and these are probably the ones that span any organization. Real-time events, we call them automations. So that's when something happens in one system, it triggers, and now you want that information or message to trigger actions in other systems. FME server apps, these are no-code web applications where now you can share the power of your data through these FME no-code apps. So anybody who has access to a web browser can now go and ask for the data they want when they want it, run reports when they want it, and things like that. Real-time data stream processing, we added that in FME 2021, and that is all about being able to pull in data real-time from sensors, from your moving assets in the field, from applications that may have data streams which they pull out. And of course, last but not least, from time to time you want to generate reports to look at trends or move large amounts of data to schedule things between one system and another. You might have disparate systems, and now you need to move the data on a scheduled task. So that's another one. Okay. So when we look at enterprise integration, this is a screenshot from FME Server 2022, and you can see on the bottom, you can see the load that's on the server. And no surprise, the load on the server is not constant. It varies. You have really busy times, and you have really quiet times. And the point is, to deliver a good customer experience is you need to return results at all times, good results at all times. So you want to hide the underlying system load as much as possible from your users so that they always get a good experience. And that's, again, we're going to talk about how to do that and have some demos on that today. And so, how can organizations meet varying processing needs? Well, and when we look at processing needs that are time sensitive, those are the ones that are really going to impact user experience, i.e., if one system triggers an event, but it doesn't get processed for an hour, now you have that lag time where the systems are not connected in real time. An FME server app, there's nothing worse than going to a web page, entering some information, but the system behind is slow, so you wait minutes or, worse before you get a response. Real-time data stream processing, as the name implies, you can have data stream information coming in really, really quickly, and you want to understand what is happening now for situational awareness, for, maybe you have fleets out in the field, and it's important that that data is processed, where things are now. And so when we look at FME, 3 of the 4 types of data flows really are real time, i.e., if we don't do them in real time, customer experience is impacted. Okay, so there's a couple ways you can, back to this flow, this server load, there's a couple of ways you can meet the peak there. You can make sure you have all the processing available to, meet the peak. That's inflexible, inefficient, because now, you have your standard FME server engines for K-SACE and FME. You've paid for all that capacity, so you have paid for all this wasted capacity. And, the peak, as you put more and more processes into your enterprise integration, that peak is going to grow over time. And the peak is often very difficult to predict. And so that's one, way to solve that problem. But when we think about FME dynamic engines, what we can do is now we can have the resources available, but we're only going to pay for what is used. And so now we're actually only going to pay for the purple line, i.e., we're going to pay for the work that we've done. So this is reduce the costs. It's because you don't have to have the engines. It's more scalable. You can add the processing capabilities in the back, knowing you're only going to pay for what is actually the work that's done. Yep. Oh. And it's also more efficient, and so that's what dynamic engines do. They give you the agility needed to meet your varying loads. Okay, so what are they? So I'm hoping to in these next few slides to remove some of the confusion around dynamic engines. Dynamic engines might not have been the best name because some people thought that it will only work in elastic environments. So we'll talk about that. Really, the big thing about dynamic engines is you only pay for the work done. That's it. So you no longer have to think about how much processing am I limited to. I have 4 FME server engines. Okay, I can only do, what those 4 engines can do, to how much processing do I need to do. And you can change the number of available engines at any time you want, or not. You can just have them sitting there. So you'll see that later as well. So how are dynamic engines different than standard engines? They're not. They are 100% the same from a capability standpoint. And in fact, they're exactly the same executable. The only difference is when a dynamic engine is started, it's told, hey, you're dynamic. So then he's going to, the server core is going to then communicate in a slightly different way. Only the pricing model is different. And so wherever you're using a standard engine, you can use a dynamic engine and vice versa. Okay, so some of the benefits: improved scalability. Now, if you have busy periods, you can easily scale, add new engines to keep that responsiveness. Improved resource utilization. You can add and remove the resources to meet the needs. Reduce costs. The deployment models ensures you're not, you can deploy it, and users are not waiting for results. And users' time is probably the most important and the most expensive asset you have. So if we can reduce the amount of time that your users are sitting around waiting for results, that means they're getting more done. So it's not just they're spending less time waiting, but they're using the time they used to be waiting to do even more. And so that's really an important point. In customer experience, if you give users fast response to requests, it keeps them happy, productive. It keeps them in the flow of what they're trying to solve. And last but not least, of course, is agility. This ability to address very easily the changing needs of your organizations as you embrace more and more data automation. And so just a couple of stories about how some of our customers are using it. Blue Dot, of course, if you click on that, they're a company that tracks infectious diseases. And of course, in last year, in February, before the world was hit with COVID, they had noticed that something was going on, and they actually provided data and warnings to the World Health Organization, and again, big FME deployment with lots of engines using dynamic engines. So when a lot of data comes, they can grind it up, but then when they have periods where they're not getting data, their engines are quiet and they're not paying for them. We have in Canada, we have 2 major rail customers. They're both using dynamic engines, and they're both using them for real-time data flow. So they're tracking their fleets, their locomotives, and they're getting locomotive location information, but also other information about the the telemetry, the health, other information about those assets. We have another one that's using data streams for tracking fleets of snowplows and lots of things like that. We have another one that's using dynamic engines with real-time data for lightning strikes, and so lots of places where users are using these dynamic engines, and often it's where the load is not entirely understood or predicted, or there's variability, or they're building their systems up, adding more and more, and they want to be able to use those. And often in a natural disaster, we just had one in BC, major flooding, loss of every highway out of Vancouver. So Vancouver was like an island now from the rest of Canada. We can't get anywhere else. And of course, at those times, the last thing you want to be doing is wondering how much capacity you have. With dynamic engines, you can deploy as many or as few. You can scale your whole infrastructure up or down, and you don't have to worry about your capacity. Basically, as many engines as you start running, is the capacity that you have. So that's just some of them. Where can I use them? Another good question. Anywhere. So most of our customers using them are using them on premise for any workflow at all. Standard machine deployments, Windows, whatever. They do not require a cloud deployment or a scalable cloud deployment or anything like that. They do work in Kubernetes, of course. So if you're running in Kubernetes, then they match the ability of Kubernetes to easily bring, you know, containers or pod engines up and down. And cloud deployments, of course, if you're running your server on your own self-managed cloud infrastructure, you can do that. And subscriptions, of course, if you want them as part of the subscription, no problem. Talk with Locus, talk with John, and we can make that happen. So bottom line is anywhere. Okay, so if you look at the two engines, again, the processing capability is identical. It's just how do you, it just comes down to the pricing model. Okay, so here we go. So driving enterprise integration agility with dynamic engines. So there's 3 capabilities. So now we're going to get into the demos. And these demos, there's 3 capabilities of FME Server that are required to really get the benefit of FME Server with dynamic engines. And they're not complex, but if you miss one, then you're not going to get the benefit of dynamic engines. So I'm going to walk through these, and I've recorded these. I recorded these yesterday when I did the demo. So then when I give you the slide deck, you're able to watch and see what I did. I can also make available all the sample workspaces and the automations and everything that I use to make these demos. I work to keep it really simple so that we focus on, you know, the dynamic engines and not get tied up in what's actually being done. So, but these 3 things give you everything you need to be flexible and agile processing across your organization. So here we go. So any questions, Artie, at this point?
Nothing in the chat so far.
Okay, yeah. Am I talking?
If you guys have any questions, please feel free to put it in the chat or put your hand up or interrupt us at any time. We're always happy to answer.
Yeah. Okay, so here we go. So the first demo is really short, but I'm going to walk through how to create this thing called a queue property. Because what we're going to do in these demos is we're going to dynamically assign these dynamic engines to certain areas in my server that are overloaded. And to do that, the first thing we need to do is to create a queue property. It's foundational to building these building agility into your solution. So here we go, and it should just play. Okay. So what I'm going to show first is how to create a property on the default queue. What I'm going to do in the demo in a second is I'm going to show you how you can have engines swarm to a queue when there's a number of jobs that are waiting. But first I need to create a property. And so I do this from the GUI. I'm going to create a property. And the type of property I'm going to create is a queue property. And I want the queue property to be number of queue jobs, and I'm going to select the default queue. Okay, so I do that. And now I'm able to actually build an engine assignment rule because I could say engine assignment rule when it's dynamic and add a rule when the number of queue jobs on the default queue is greater than 0. Okay, and then I would simply pick the default queue. Okay, default job assignment. Queue overload like that. And so what that's going to do is it's simply going to, for every engine that's dynamic, if the number of queue jobs on the default queue is greater than 0, then it's going to assign that to the default queue. So I say, okay. And so that's how you create these number of queue jobs by a specific queue. Okay. Okay. Now in theory. So what I'm going to show. Okay. So that one piece there, I pulled that out because when you go to try this yourself, that's the one thing you may forget. the user experience may not be as smooth as you would like, and so it'll probably get easier over time. But that is one of the key pieces. So now to the real demo. So the first demo I want to do, because this comes up, is imagine I'm a company, AB Acme, and I have my FME server, and it has 6 standard engines. And but from time to time they get overloaded. So, but I have some dynamic engine time. So what I want to do is I want my dynamic engines to assist with my server, but only when my engines are busy. So that's this first demo. So I have all the engines on serving the default queue, and everything goes great. But sometimes the default queue gets backed up, and at that point, I want my dynamic engines to step in to relieve the pressure on my system. I don't want to use them all the time because I want to maximize my standard engines, but that's what I want to do for this first demo. And it's really simple. This is just a screenshot before we get into it. But essentially, I'm going to create 2 rules. One is I'm going to create an idle queue. I'm going to create a brand new queue called idle, and I'm never, ever going to assign a job to that. But what I'm going to do is I'm going to say I'm going to create a property, and the property says, if you're a dynamic engine, then always listen on the idle queue. And so it'll sit there. And the other property I'm going to do is this one we just created. I'm just going to be the default queue overload, and I'm going to say, if you're a dynamic engine and the number of queues default is greater than 1, then I want you to, then you're going to go to the default queue. And so what's going to happen now is you'll see in this this video, you'll see how this works. It's really, really simple. And so here we go.
Okay, so this is the first demo. I'm going to first show you how to start dynamic engines, show you where you can see how much time you have left, and then we're going to walk through this first demo on how you can use dynamic engines to relieve load on your standard engines. So in that scenario, they'll only be used when your standard engines are busy at the time of launching. Okay, so here we go. So let's take a look at this system. So first of all, if I go to licensing, you're going to see I have a bunch of dynamic engine time there. And now we're going to take a look at the engines, and you're going to see I, in fact, do not have any dynamic engines running. So the first thing we're going to do is we're going to start some. So I'll put 4 on each machine. And it's as simple as this on Windows. On container-based systems, you would launch these engines from within Kubernetes or Docker or whatever externally, and they would register. But in Windows, which is our biggest one, you can do it. So the other thing to note is there's nothing, I don't have auto scaling going on. I just have 3 machines, and I'm just using dynamic engines as a way of leveraging those machines. So you don't have to have dynamic engines only for cloud-based or infrastructure in which you're adding and removing machines. In this case, I just have those 6 machines, and I'm able to create these dynamic engines. Now, these dynamic engines running do not in any way use any CPU. They're just sitting there, and you'll note right away that they're on the default queue. And this is not really what I want, because in this case, what's going to happen is when a job arrives to the default queue, I don't know which engine's actually going to get it. So that's not really what I want. I want the dynamic engines only to be used when the standard engines are all busy. So to do that, I'm going to create an engine assignment rule. I'm going to create a new one, and I'm going to call it the idle dynamic engine rule. Okay, and I'm going to say for any engine that has a property of dynamic, I want to assign it to the idle queue, just like that. Okay. So now I say okay, and now if I go look at my dynamic engines or my engines page, you're going to see that all the dynamic engines are assigned to this idle queue. And so that means they will never be given jobs unless a job is assigned to the idle queue. And I'm never going to do that. So just to illustrate the point, I have an automation here which assigns 4 jobs at a time, okay? And I know I have 6, so I'm going to trigger this twice. Okay, so I'm going to trigger it once. Okay, and then I'm going to trigger it again. Okay, and now I'm going to go over to the jobs, and you're going to see I have 6 jobs running, 1, 2, 3, 4, 5, 6, and queued. I have 2 jobs waiting because they're all assigned to the default queue. And when I go looking at the default queue engines, you're going to see all 6 engines are running, but none of the dynamic engines ones are. And no surprise, when I go to system configuration on licensing, I haven't done anything because the dynamic engines have not been assigned. So now what I want to do is I want to tell the dynamic engines when all the standard engines are busy, then go and help them out. So again, another engine assignment rule, really simple. I'm going to go here and I'm going to create a rule. I'm going to call it the default queue overload rule. And I'm going to say it's a property, and when for engines that are dynamic, and when the number of queues in the default queue is greater than 1, now I'm going to assign that dynamic engine to the default queue. So I do this, and now what you're going to find is, if I go back to my jobs, let's see if my jobs are still running. Okay, jobs queued. Oh, there's no jobs queued. They're all running. I'm going to go back to my engine management, look at my engines, and you're going to see, oh, this idle one, this dynamic one did get a job. So it came in just in time. All the other ones are now at the idle state queues because the queue is not, in fact, being used. So you can see that those 2 jobs did launch when all the standard engines were busy. It was given to those dynamic queues, and then they do the job. So if I submit some more, 4 more, you'll see that, in fact, if I go here, and I trigger, automation trigger, look at the jobs are queued, they should all be running, look at the ones that are running, they're all running on the default queue, go to the engine management page, engines, and you're going to see that the standard ones have the jobs, standard, and those 2 other idle jobs have yet to be finished. So there you go. So that is how you can use dynamic engines to relieve the load. Okay, so we'll give this a minute. These will finish pretty quickly. Okay, the queue jobs, there's no queue jobs, running jobs, there's 4 now. And we go down here, and engines, they're all off the default queues, okay, because they're all idle, and now we're back into this state before. And so again, now if I submit 4 more jobs, assuming I have enough standards, so I have 1 here, 1 here. Okay, no, I don't really have enough, but once they're all free again, we get back to our state. And again, the dynamic engines are only used when the default queue is busy. So there you go. That's our first demo. Okay, so
Okay, so that's the first one. Any questions on that?
Nothing in the chat so far.
Okay, good. So so the second demo is, and you're going to see a theme here. The second demo with dynamic engines is, in this scenario, from time to time, there's big processing that may hit your server, and you don't want the natural throughput of your server to be impacted. So in this demo, we're going to see how with automations, it's easy to perform parallel processing with FME server, and in order to get results quicker. And what I'm doing here is, again, I'm going to use dynamic engines and engine rules on FME server to do that. So there's a number of components. There's the automation, which you'll see in a second, dynamic engines and engine rules. So yeah, and here's the automation, and it's triggered by a schedule. I'll trigger it manually. And what happens here is one message comes in, and then a workspace called process state is created. It does some work for a particular state. And as additional to state processing, what it does is it outputs a new message for every county. So in this particular case, there's going to be 30 jobs that come out of here. So now 30 of these process county jobs are going to come out at the same time. They're all going to be launched based if I have enough engines. And so you can do all this processing in real time. And then what's going to happen then is each process county does some work, and then it outputs a bunch of these blocks. And if we counted them all, we would see that at some point there's about 900 of these, 30 of these, and one of these. So there's 931 jobs. And what this split merge block is all about is parallel processing. And so what it says is a message isn't going to come out of here until all the work inside this split merge block is completed. So it will wait until all the work is done. And then at the end, I have two other workspaces. I have a downstream work and then a log. I'm going to log some information. So the key part with dynamic engines is you're going to note that I assign the queue to a county block here, and a county queue and a block queue. And then again, have dynamic engines swoop in, do the work, and then return. So here we go.
Okay, in this one, I'm going to show how we can do heavy-duty processing, but have it moved off of the default or regular working flow of your server. So in this one, again, it's going to be triggered by an automation. And it's this one here. In this one, what I'm doing is I have an automation which is doing some massive amounts of parallel processing. So the idea is when it's triggered, a message comes in, and we're going to process the specified state, which is then going to do some work, but then it's going to spin off the process the counties. There's 30 of those counties in the state. And then within each county, there's a certain number of blocks. And so in the end, there's about 900 jobs here, about 30 jobs here, and about 1 job here. And this is going to be, as I mentioned, parallelism. But what I don't want to do is I don't want this to smash my entire server. So I want this to go to dedicated dynamic engines. So the first thing I do is on each of these is I'm specifying a queue. So I say, let's put the county jobs go to the county queue. And the block ones go to the block queue, and the state one is going to go. It's just going to be. He's just going to live on the default queue. Okay, so that's what I'm going to do there. So that's what we're going to do there. So now we go back to our engine management on engines, and it's going to be it's going to be the same kind of thing. So right now, as you recall from the previous one, we have all our dynamic engines. They're sitting on idle, not doing anything unless the standard queue becomes super busy. But now what we want to do is we want those to take over this. So again, it's on engine assignment rule. So here is the default one. I can turn that off if I want. I could go here and say action disable. And now what I've done is I've created two different ones. I have one for the blocks and I have one for the counties. You'll still see I have this idle rule that stays there because I don't want the dynamic engines when they're not busy to go to the default queue. I only want to use it at certain times. And so if I look at the counties, then you can see, the county rule is when the engine is dynamic and the number of queued jobs is greater than 0, then I'm going to go to the county queue, okay? And that's that one. And on block, it's the same.
when it's dynamic and the number of queue jobs in the block is greater than 0, then we're going to go to the block. So we're going to say, okay, and so now that's it. You'll see the engines here, they're sitting. Now when I go and I run the automations, I go manage, and it's this one here, process parallel block testing. And what you're going to see when I start this guy, and then when I trigger him, is you're going to see lots of jobs go. Okay, so I'm going to trigger it. The job's triggered. Okay, so now I'm going to go to the jobs queued. And initially you're going to see a bunch of counties are on the county queue. And if I go to engine management of engines, you're now going to see all the idle ones have jumped over to the county queue. And you can see they're processing counties. Well, if I wait long enough, you're going to see that now I'm also queuing blocks. So there's the counties. Oh, there's some blocks now. So the block queue is going to have something in it. So now if I go over to engine management on engines, you're going to see the idle ones are going to be, when they, important point, they will switch when they are finished processing a job. So these engines don't switch, while they're in the middle of a job, because why should they? Because they're busy. But once they finish processing a job, and then the job rules are reevaluated, and then they will process the blocks. And so if we look at running now, you can see we're processing counties still, and engines. And now you can see they've all gone to blocks because they finished. They may still be processing a county, but they now reevaluated their rules and they noticed that the blocks. Okay, you can see now that where all the counties are done, and so the dynamic engines have now dropped that queue because that queue is empty, and now they're just back to the block queue. The other thing you're going to note is that the default queue is untouched and always ready for processing the standard workflow. So in this way, what we've done is we've shown how you can use engine rules with dynamic engines to do heavy duty processing and do it off to the side of your normal FME server processing, so you're not impacting your regular server workflow. So now you can see that all the jobs are completed. There's none queued and there's none running. And if I go back to the engine management, you will see that all the engines are back on idle parked. And so there you have it. If we look at the licensing, you will see that we did in fact burn some credits, as one would expect. Okay, in this one. Okay, so yeah, so that was another example. And any questions on that one, Artie?
Nothing in the chat so far, Don.
Okay, okay. So people are speechless. My humor is much better in person, but anyway. So yeah, so the third one is, we remember at the beginning we talked about, you know, dynamic engines coupled with engine rules and job rules. Well, you've seen the power of engine rules. It enables us to look at the various queues on server and then assign the dynamic engines to where there's work to be done. The next type of rule is called a job routing rule. And in this case, because we pay for CPU time with dynamic engines, if you have jobs that spend most of their time waiting around for data, could be a web service, or maybe you have a dedicated engine on a stream getting data, a data feed, but you know what, there's long periods of time where there's very little data or maybe none. We have one client who was using data streams, and they noticed that at 5 p.m. on Friday, they would get a message, and then they actually wouldn't get another message until Monday morning, as it was this thing was measuring, you know, the cars going in and out of their office kind of thing. And of course, on the weekend, there was nobody there. And so they were getting very few or no messages. Well, to have an engine, regular engine sitting on that, when it's not doing anything, doesn't make a lot of sense. But a dynamic engine can. And so if only we could give, there's a way on FME server to get access to job statistics. And that's something else we added in FME 2021. If you look at any job or any workspace, you can actually see the percentage of CPU that is used. So that's simply the CPU time compared to the elapsed time. And you can see on this particular server here that I have a number of jobs that the CPU time is very small as a percentage. Oh, we have one here where it engages multi-threading, so the CPU time is actually more than the elapsed time because we're actually using multiple CPU cores at the same time. But and so what we're going to do in this next demo is we're going to show how I can use dynamic engines so that it processes jobs that have less than 10% of average CPU. So that's what we're going to do here. Okay.
Okay, in this demo, we're going to show how you can use dynamic engines with other capabilities in FME server, i.e. job routing rules and engine assignment rules, to offload work that you consider to be low CPU usage to a dynamic engine. This might better fit with pricing model dynamic engines, as you pay only for the CPU use. So by offloading these light jobs, you can more effectively handle your processing. So here we go. So first of all, I'm going to create a queue. So I'm going to go into queues, and I'm going to create a new queue we're going to call light. Okay, for light jobs. Okay, just like that. And now I have this new queue called light. And so what I'm going to do now is I'm going to use a job routing rule, and I'm going to say new, and I'm going to say, we're going to call this light jobs. And we're going to use job statistics, and we're going to say if the CPU is less than or equal to 10%, then let's send it to the light queue. And that's it. It's now, what that's going to do is any job that is submitted is going to be sent to the light queue. So we can give that a try. So we'll go here, and here I have this job called light, and I'm simply going to run it. And there we go. So this light job is queued. And of course, if I look down on my queues, I'm going to see it's there. If I look at my jobs, I'm going to see there's this light job that's on the queue. But if I look at engines, you're going to see that there, in fact, at this point, is no engine that's actually assigned to light. So we've seen this before. We're going to create an engine assignment rule, and we're going to say new, and we're going to. So what I need to do now is create a property. So I'm going to create a new property, and it's going to be a queue property. I'm going to select the queue property, which is number of queue jobs, and I'm going to select the queue as light. Okay, so now I've created the property, and so now what I can do is create a rule and say if it's dynamic and the number of queues on the light queue is greater than 0, then I'm going to assign it to the light. Okay, so I do that, and immediately now when I look at jobs, you'll see that a job is running that one. I go back to the queue control, and you will see that it's there. I look at engines, and you're going to see that all the engines are only on the idle, and the light job is processing the job, And when that's finished, it will again go back to just idle. And of course, if I ran another job, another light one, run, do the same thing. If I go to run another one, this one I'll run fast, same thing, and the jobs are okay. So now if I go to jobs, running, you're going to see all those 3 jobs are running on the light queue. If I go to engines, you will see that that one's light, and the other one light. Okay, and again, this ability to control what types of engines are processing jobs is really key, and it's really easy to do. So there you go.
Mm-hmm.
Okay, in this demo, we're going to show. Okay, in this demo.
There we go. Okay, so yeah, so that concludes the demos. Before I go on, any questions on any of that? No. Okay.
Still speechless in the chat.
Yeah, I apologize for some of the sound. For some reason, on some it's loud, and other ones it's quiet. But anyway, so yeah, so how can you get started with dynamic engines? And really, it's as simple as reaching out to John at Locust and sharing what you need and what your challenges are, and then we can working with John, we can get you going. They really are as simple as I've made it look, and that's really been the goal as we've built this. We've tried to make this concept easy to understand, so that then you can focus on solving problems rather than wrestling with our interface. There are a few things that I kind of glossed over that but I'll talk about them now just because I'm not in marketing. When I submitted like that light job, and by the time I went to engines, only one engine got access to the job, and so then the other ones backed off. But it could be what we've seen in some of our testing with large servers with thousands of engines is what tends to happen is all the engines would go to one queue and all the and then all to another. But you might want a queue where the maximum number of dynamic engines to one queue is 3, and another one is 4, and another one is 2, and things like that. So then you wouldn't have all your dynamic engines going to a particular queue, because you might have some queues that are higher priority, and so maybe you want to allocate up to 10 dynamic engines for that, and other queues are lower priority, so you might only want a maximum of 2 or something for that. And that's coming. That's in FME 2022, we're continuing to extend and give you more flexibility as far as how you control your resources with FME server. So certainly, if you try this, let us know what you like and what you don't like, and because this is definitely where we're going with FME server. We want FME server to be able to enable you to use all the resources that it has as efficiently as possible, so you're not noticing that somebody's job workflow is backing up, but then you have these engine resources that are sitting idly by. So yeah, so a little bit there. And really what I tried to demo this today was how easy they are to use, because I don't ever want you to watch me do a demo and then the takeaway is, wow, that guy really knows what he's doing and he's really smart. Neither of those is true, but I want you to walk away thinking, I can do that. I get it. I can see how I can start to engage with this and try things such that it adds value to your organization. There's nothing, we have enough complex solutions and complicated things that we have to all deal with on a day-to-day basis. And our goal is always to make this one really, really simple. And that's why I also embedded these videos in this slide deck. I'll share it with you. It's a Google slide, and then all the videos and everything is in there. But yeah, so any questions or discussion?
Yeah, we have a question from John over at Locus. He's wondering where SAFE sees the growth within Dynamic Engine, being conscious of the fact that it's a relatively new solution that we've added to the FME platform.
Yeah, no, that's a good question. The two areas that we're seeing, well, there's three areas that we're really seeing a lot of growth in at SAFE. The first is subscriptions. So we're seeing a lot of take up in subscriptions because organizations then can grow their deployments really easily. The second is dynamic engines, where organizations they try them and now they're buying more and more time. And I think that one was up like 700%. Now, of course, 700% is something they were introduced in 2021. So I think only one quarter in the previous year, but quarter after quarter after quarter, we're seeing more organizations embrace them. Often they want to start small and understanding, what, the impact and what they actually need. And of course, the last area we're seeing lots of growth in is in, cloud deployments of FME. Yeah. Okay.
Another question from Ruby. In terms of value for customers that want a robust schedule, when does it make sense to use traditional engines versus dynamic and vice versa?
Yeah, that's really why, like, dynamic engines are built to the second, so of CPU time, and so you can reach out to get information, the procurement costs or whatever. But that's one of the reasons that we added the CPU percentage on all the job information in FME server. So then you can make an intelligent decision on, hey, this job really spends a lot of time waiting for data. So that one, and i.e. the percentage of CPU is really low. So that's a great candidate for dynamic engines. And that's why I showed that last demo, because that is a case where more and more FME spends time talking to web services, and web services are inherently slow compared to a CPU. So while they may seem fast, 100 milliseconds is a long time for any application to be waiting, and that's not atypical of a web request. And so it fits really well with that. It also fits well with where we're going with cloud deployments, where in fact the server can scale up and scale down, and we're working hard on that. With future Kubernetes deployments. The problem with Kubernetes right now is not scaling up. Scaling up is easy. It's scaling down that's hard, because when you scale down in Kubernetes, you can view all the engines as worker. It's basically a worker pattern where you have a whole bunch of workers doing a particular task. Problem with Kubernetes is when you scale down, currently it randomly kills a worker. Well, that's not great, because you don't want them randomly, because the worker that it terminates, good chance that it's actually doing real work. So now you've lost that real work. But we're leaving that as a Kubernetes problem, knowing that Kubernetes is working on that. And if you dig into Kubernetes, you'll see now there's a technology preview out there that allows for intelligent scaling down of resources, because to have a fully scalable solution, you want to be able to scale up, but you also want to be able to scale down. So that's really where it gets exciting. Having said that, we have most organizations are running on premise with their own hardware, and they have dynamic engines just exactly as I did, and that's why I chose to use a Windows deployment. This Windows deployment is actually running on Azure. If you go to the Azure Marketplace, you can simply launch a distributed FME server through their GUI. So that's what I'm using here. And standard engines are great. They have price certainty. You don't have to worry with standard engines that some user we would call Billy Bob. At SAFE we talk a lot about Billy Bob. That Billy Bob got a really brainy idea, and he ended up, just burning through just tons and tons of time and launching like 500 dynamic engines or whatever. But those situations are probably not that real. Most organizations today have a mature, data processing IT infrastructure. So I would say the biggest case for dynamic engines, and I tried to hit them here, is as overload on your server, sort of as, I don't think I'm going to need them, but I have a few hours, or heavy duty processing, like we saw there. And this could be in an emergency. You know, and in emergencies, often you don't know what data you're going to get or what reports you want to run, you know, and things like that. And often, the results of these things you're doing are people's lives. You have people who are responding to the emergency, and you want to make sure that you're not slowed down. So if things go the wrong way, you can get your people out to protect your people and infrastructure. So that's the other one. So there's those three examples I gave. Those are the ones that, if I look at things that resonate. There's a fourth one around real time, where you have a real time data flow. I didn't build that one here, but it's very much the same. You assign you have a workspace that's locked on to a real-time data source, and you simply launch that as a data stream. So yeah. So this slide I have up here now is really to invite everybody to come to Vancouver to attend the Peak of Data Integration. That's the name of our user conference, and there's been people from all over the world. It's a beautiful spot right on the water, and we're really looking forward to seeing people in person again, as I haven't been on the road in 20 months or so, since March of 2021. So it's been a long time, and I used to be on the road a lot. So it's been good in some sense. We've been able to focus and get a lot done, but I really miss, getting out, meeting people, meeting customers, understanding, data challenges and how we can make FME even better. I miss John too. One of my last trips actually was to New Zealand and Australia, so it was great. So, yeah.
I'm missing you guys too.
Okay.
Okay, everybody. Well, look, Don, thank you so much for making the time to deliver that session today. On behalf of Locus and our customers, we really appreciate that. And I don't think we've got any further questions, so we can probably wrap things up now.
Great.
I think we mentioned earlier that we will, of course, make this recording available to everybody that's attended today, and thank you for doing that in terms of the demo content in the slides. So we'll be sure to share that. Yep. And excellent. Thanks so much.
Yeah, well, thank you, and thanks everybody for attending. Really appreciate it, and maybe next time I'm actually there in person, which would be great.
Would be fantastic. Yeah, let's hope that's not going to be too far away.
Yeah. So great.
Okay, well, thanks all. Enjoy
Awesome.
the rest of the day.
Thanks, everyone.
Bye-bye.
Okay.